So today's video is on alcohols and their oxidation reactions. So first we're going to have a brief overview of alcohols. And so we know that alcohols are a homologous series with a functional group of OH, R-hydroxyl. And there are three types of alcohols, which are primary, secondary and tertiary. And a primary alcohol is where our hydroxyl functional group is at the end of a chain. So if you see here, our hydroxyl group is bonded to a carbon, which is bonded to only one other carbon, and this is because it's at the end of its chain. A secondary alcohol is where our hydroxyl functional group is in the middle of the chain. So you can see here our hydroxyl group is bonded to a carbon that is bonded to two other carbons because it's in the middle of this chain. And a tertiary alcohol is where the hydroxyl is bonded to a carbon that is bonded to three other carbons. So you can see our hydroxyl group here is bonded to a carbon that is bonded to three other carbons. So what are the two types of category of alcohol? So first is aliphatic, and these are straight chained or branched alcohols. And then there's aromatic alcohols, which are cyclic alcohols, for example, phenols. And you can see up here the structure of a phenol. We have our cyclic structure with our OH functional group. So now quick overview of the properties of alcohols before we get into the oxidation. So our OH bond is our functional group, and this OH bond is actually polar, and this is because oxygen is more electronegative, and electronegativity is how strongly an atom attracts its bonding electrons. So because our oxygen is more electronegative, it attracts the bonding electrons in our OH bond more. So this leads to an uneven charge distribution. Our electrons are unequally shared. Because our oxygen attracts these electrons more, the electrons will be closer and around this oxygen more often than the hydrogen, inducing partial charges. So our oxygen will gain a delta negative, a partial negative charge because the electrons are closer to it and around it more, while our hydrogen will gain a delta positive charge, a partial positive, because the electrons are not around it as much, they're further away. And it is these partial charges that allow for hydrogen bonding. And hydrogen bonding is the strongest type of intermolecular force. And so this hydrogen bonding is between positive hydrogens, and we have a delta positive hydrogen formed by this polar OH bond. So it's between positive hydrogens and a lone pair of electrons on an oxygen. So a positive hydrogen on one alcohol molecule will form a hydrogen bond with a lone pair of electrons on an oxygen of another alcohol molecule. So this will form our intermolecular forces. And this is why alcohols have much higher boiling points than their equivalent alkenes, because hydrogen bonding requires much more energy to overcome. So our alkenes don't have this hydrogen bonding, therefore their boiling points are lower because they don't need this extra energy to overcome this strong intermolecular force, these hydrogen bonds. And our alcohols are soluble, and this is because the OH bond can interact with the polar water molecules. However, our solubility decreases as the chain length increases, and this is because the effect of the soluble OH group decreases. So the ratio between soluble and insoluble decreases because our chain length is increasing, and our carbon chain isn't soluble, it's only our OH. So the effect of this soluble OH decreases as the length of our carbon chain increases. So solubility decreases. So finally on to the oxidation of alcohols. So oxidation is the addition of oxygen or the loss of electrons. And an oxidizing agent is a substance that oxidizes another by reducing itself. So it will give up oxygen to allow another to gain oxygen to oxidize. And the oxidizing agent for alcohols is acidified potassium dichromate. And always remember to put the acidified part at the beginning, because potassium dichromate is not an oxidizing agent for alcohols in itself. And you can see up here, this is the molecular formula for potassium dichromate. So in this oxidation reaction, the colour change is green to orange. So our acidified potassium dichromate allows this colour change so we can see when it's not oxidized and when it is oxidized. So we can remember this by OMG, orange makes green. So now we're going to look at the oxidation of different alcohols. And we know our three types are primary, secondary and tertiary, and all three of these have different oxidation products. So first we're going to look at primary oxidation. So in excess alcohol, a primary alcohol will form an aldehyde when oxidized. So you can see here we have our primary alcohol because the OH group is at the end of a chain, and it reacts with our oxidizing agent, our acidified potassium dichromate, to form an aldehyde, and this is the functional group of an aldehyde here. But in excess oxidizing agent, we form a carboxylic acid. So our aldehyde will form, yet if there's excess oxidizing agent, our aldehyde will just continue to react. It will further oxidize into a carboxylic acid, which has the functional group here. So our general equations are alcohol plus our oxidizing agent will form an aldehyde. Yet in excess oxidizing agent, our aldehyde will continue to oxidize into a carboxylic acid. And our colour change is going to be orange to green. It's going to be not oxidized to oxidized. And this colour change will show us when it does oxidize, which is very useful when trying to identify products. So now moving on to oxidation of secondary alcohols. So a secondary alcohol will be oxidized into a ketone always. So our alcohol plus our oxidizing agent will always form a ketone when it's a secondary. And it's also important to note that our hydrogen in our hydroxyl and a hydrogen bonded to the same carbon as our hydroxyl and an oxygen from our oxidizing agent forms a water molecule. So hydrogen from our hydroxyl, hydrogen bonded to the same carbon as our hydroxyl, and an oxygen from our oxidizing agent forms water. You'll see why this is important in a minute. But it's also important to note the colour change, and this is going to be orange to green. It's not oxidized to oxidized into a ketone, so secondary into a ketone. And then finally, our oxidation of tertiary alcohols. And a tertiary alcohol cannot be oxidized. And this is because there is no hydrogen bonded to the same carbon as our hydroxyl, as I pointed out in the last slide. So in our primary and secondary oxidation, water is formed from our hydrogen in our hydroxyl and a hydrogen bonded to the same carbon as our hydroxyl and an oxygen from our oxidizing agent. But because a tertiary doesn't have a hydrogen bonded to the same carbon as the hydroxyl, it cannot form this water, so it cannot perform this entire oxidation reaction. So a tertiary alcohol cannot be oxidized. So the colour change, there is no colour change. It stays orange. It stays unoxidized. So in summary, a primary alcohol will form an aldehyde in excess alcohol, but with excess oxidizing agent will further oxidize into a carboxylic acid with a colour change of orange to green. A secondary alcohol will always form a ketone when oxidized with a colour change of orange to green. A tertiary alcohol will form no oxidation product, so it stays orange because tertiary alcohols cannot oxidize.